Okay guys, this video is going to be about my 24-inch Dobsonian and using the Ocal 4 collimator to collimate it. You'll see my complete routine for collimating the 24 out in the garage, although we did have a little bit of a tricky moment where I didn't realise that when I was doing some maintenance on the scope, I left a big nut down underneath the mirror housing so I could lift it up to clean and get all the crap out of there, and I didn't realise it was there, so it stopped me collimating all the way to the completeness on the first pass. But as soon as I did see that nut there and removed it, I went back and I completed the collimation in there. And then last night we went outside on the Saturn, and I can show you the final positioning of the mirrors as I did a quick screen record on that when I was outside. And then we went on to point the scope, dodge the clouds in the middle of the clouds. We went on to point the scope at Titan with this configuration, which for me is 4,700 millimeters of focal length. This one is 10,200 when I use this Barlow. But anyway, at 4,700 millimeters of focal length, we point the scope at Titan, slightly defocus Titan, so the center section of the secondary starts to just break out, and you'll see that the collimation was essentially perfect at 4,700 millimeters of focal length. Very, very close. I probably wouldn't have bothered to make any adjustments. At 10,000 millimeters, there may have needed to be some adjustments, but definitely the Ocal 4 just continues to impress, and I'm very, very happy that that I reached out to them and how this thing works. It's doing a stellar job on my scopes and for my situation, which is an older guy with slightly failing eyes. So take with that what you will, but Ocal 4, superb bit of gear, and glad I've got it in my kit. All right, let's have a look at all the footage. All right guys, so I've basically disturbed the whole scope. The only thing that hasn't changed is the primary mirror is centered within the mirror box. I think it's like 55 or 56 millimeters from each outside edge, which is what I said before. On these types of scopes, it needs to be positioned from, measurements need to be taken from the outside edge of the mirror box. As you can see, it's totally out of whack. I've undone it all, and we'll go through it and we'll tighten it up and we'll get it in line. I just want to show you something with the focuser. I was talking about tolerances of a focuser. If your focus is not any, hasn't got very fine tolerances and good fit, then you're going to struggle. And I just want to show you what we're dealing with on the 24. So as far as tolerances of fit. So here we are looking at the focuser on the 24. And I just want you to have a look at the amount of play there is in it. Remember in the first video we talked about having a focuser with minimal slop or minimal movement? See that amount of movement there? Like probably less than half a mil. And it's like that because they're not even tightened up. Like you can slide them in and around once it's not, but that vertical movement in there would be less than half a millimeter without them being tightened up. And the same goes with the movement. Like look at this. I mean, don't look at the end out here, look at the start, because this will be where that will be less than half a millimeter as well. Okay, so you can see the focuser on the 24 has got very good tolerances, and it makes it easier to collimate. So, but let's get into it. I've landed over at this position. Normally I'll probably collimate it a little bit higher up, but this will do just fine. I'll normally attack Saturn at the earliest at this stage of the year. It's up nice and high, and I'll always do a final collimation on a star or usually one of Saturn or Jupiter's moons. Every time I move to a new target, when I'm doing planetary, at those very long focal lengths, I'll always collimate again on a moon, or like Neptune, you can do Neptune on its own because it's not that bright. And what you do is you just defocus it a tiny bit so the center, the secondary starts to break out in the center, only just break out, and you can see that it'll start to break out from a corner, and then you'll adjust the primary to get it to break out when it comes out of focus from either side. So either side equally. All right, let's get into it. Enough talk, and we'll see how we go. So I've had this one for a few years now, and it's a scope I love using, and I've really been enjoying using it for planetary just recently. I'll turn on the screen recorder, come down here, Ocal, screen recording, yep, turn on camera. Put it up in the top corner. We want to get zoomed right in with this 2000 millimeters of focal length. Now, first thing we want to do is we want to make sure, that looks horrible at the moment, but we will see in a second. We'll make this a bit thicker. Our green ring, we are going to centralize it on the outside of our focuser. Everything starts at our focuser and it works from there down and back up. So in order to get this aligned with our focuser, we need to get the offset in action and make sure it's perfectly aligned. We'll go over to camera control. We're going to go for focus. We want we'll go back a tiny bit. It's pretty spot on there. Move this out of the road. Go down in size. All right, what have we got here? We could probably go up a tiny bit. It's going the wrong way, Dopey. Oop, no, it wasn't. Go down, that's pretty spot on, and we'll go horizontal. Wrong way, always going to be the way. Can you see that on the screen? Hopefully you can. All right, so now we know the Ocal is lined up with the end of the focuser, and then everything else going away, we have to line up with the other concentric circles. So we'll come here to red, we'll make it a bit thicker, and we'll adjust this exposure. That's better, and we'll get the focus. Get the focus on the secondary. Righto, we might even zoom in. Use the mouse pad to zoom in. That'll do us for the moment. So I'll take this opportunity to try and align the primary in the secondary, and also make sure the secondary is housed roughly around the red circle. So we'll make it a bit bigger so it will roughly reflect the size of our secondary. That's pretty close. And now my goal is here is to position the secondary so it's within that red circle, and also adjust the secondary adjustments so the primary mirror is within the secondary's view. So let's see how we go. Might move this a little bit closer. You'll still be able to see that on screen. So as you can see here, like it's just all over the shop. What do we got there? So it needs, okay. Is it going to work? It's not too bad. I might get another line up and we'll just adjust this one. So you look at that and you think, oh yeah, that's pretty good, but it's nowhere on F3.3. It's nowhere near where it needs to be. So we might make it a little bit bigger, and then we'll centralize. We let go of that one. What's that do? So that one goes top to bottom. Which way does this? That goes the other way. Oops, that's the one we want. We want tighten that way. Loosen this one. Loosen. No, we don't want that. We definitely want to loosen that one. This is where it gets tricky with a big heavy mirror. Righto. We're getting there. It's looking close. Oh, that's too tight, that one. Let that go a little bit. Sorry for the silence, concentrating. And then one last one. I think that's pretty good. Okay, so we know now the green line is aligned with our focuser tube. The red line is aligned with our secondary mirror, the outside of the secondary. Our blue line is aligned with the outside of the primary. And if you haven't watched the other video, I'll link it up here. But this is why the primary mirror center spot does not come into use with this system if you don't want it to, because you're actually like positioning the mirror on the outside rather than the inside. So these are concentric circles, software generated. So they will tell you that the outside, as long as your mirror is a circle, your center will be exactly where the center dot is supposed to be. So when we come back down and we have a look, we'll put the crosshairs on, which again is software generated, and then that will show you exactly where the center should be. And if it's not on top of the center dot, don't worry about it. Your center dot may be out a couple of millimeters. As I said in the first video, my 10-inch Dob was probably out by 3 or 4 millimeters. And until I found that out, I was having trouble. And then I worked it out. So let's make this a little bit bigger. And we're going to zoom in again, and we're going to change focus. Come back over here, zoom in one more time. So you can really see the resolution of this. This is at 1200 millimeters of focal length, and we're still getting a pretty good picture. This is, for me, am I getting older eyes? This is unreal. Like, it's really, really is good. I was just having trouble with Cheshires and that, the millimeters. One couple of millimeters here and there, it really makes a difference on this scope. So as you can see here, whether my circle is perfect or not, but it's saying that center, it looks to be that center dot is maybe out by 1 or 2 millimeters. If my centralizing circles are correct, this software generated circles and the cross should be also correct. It's saying that possibly the center dot is out by a couple of millimeters, neither here nor there. So it's no problem. All right, so let's go down. We'll actually take that off because it's close enough for this example. And let's go and align. I will get my Allen key out, and I'm going to drop this laptop down so I can view it, and then I'm going to reach in and make the final adjustments with an Allen key, and you'll be able to watch on screen the center dot move across. Let's see if we can zoom in a little bit more. Look at that. How far can you go? Right, that's maximum there. Let's see what kind of focus we can get at maximum. Go back the other way. Righto. So I think that's pretty close to what we're going to get there. So I'm going to put this down lower so I can watch it, and that's the other benefit. I can watch it in real time. I don't have to go to the back of the tube, make adjustments, and then walk back up, look in the eyepiece, look in the Cheshire, whatever you want to do. This is perfect for me. Righto, let's get down here. Got one more down here. Okay. So we'll try the right hand one first. Righto. Go up here, a couple of turns. I only ever use 2 adjustments on the primary mirror. You only need 2 adjustments to find collimation. You don't need any more than that. 2 adjustment angles to find collimation. You can watch that right here now. And it's the same when you're out at night. You only ever need 2. You start doing 3, you're going to get crossed up and